Welcome to the deep dive. Our mission today, we're tackling that classic first project, blinking an LED.
Sounds simple, right?
Yeah, but we're using the ESP32. This chip is, well, it's everywhere in affordable IoT, super
Right.
powerful, low cost, and it packs Wi-Fi and Bluetooth.
Exactly. And getting that first blink working, it's actually fundamental. It means you've lined everything up, the hardware, the software, the inevitable troubleshooting.
So to make this easier, you're saying we stick with the Arduino IDE.
We are. It's familiar territory for many, and honestly, it makes programming the ESP32 much more straightforward, especially when you're starting out.
Okay. But isn't using the Arduino IDE kind of limiting for such a capable chip? Why not use its native tools?
That's a fair question. Think of the Arduino IDE as like a universal adapter here. It lets you use libraries and functions you probably already know.
So you can focus on the connectivity, the IoT part, without getting totally stuck on, super low-level chip details right away.
Precisely. It's a huge leg up for getting real IoT projects off the ground faster.
Okay, let's unpack that setup then. First thing, the IDE doesn't magically know about the ESP32. We need to tell it where to look, right? Like installing a map.
A map is a good way to put it. You need to add a specific URL. We'll definitely link that in the show notes for you.
Right, into the preferences section.
Yep. And then you go into the boards manager, search for SP32.
And install the package from Espressive Systems.
That's the key step. That download contains all the definitions, the translations that let the Arduino IDE talk to the ESP32. It's what separates standard Arduino from this.
Okay, software map installed. Now connecting the actual board, this feels like, well, the first big hurdle where things can go wrong. Why is this simple step so tricky sometimes?
Oh, it's almost always one thing. The USB cable.
Really? Just the cable?
Seriously. You need a proper data transfer cable, not just any cable that fits. So many of those are charge only.
And those will just fail during upload.
Exactly. Errors, connection timeouts, frustration. And if the board doesn't even show up as a COM port,
And it's drivers.
then it's drivers.
Yeah.
For that little USB to serial chip on the board, often a CH340 or maybe a CP2SNX, you might need to install those manually.
So hurdle one isn't code, it's basically prove you have a good cable and the right drivers.
Pretty much.
Okay, assuming you pass that test, you select the right board in the IDE. Something like ESP32 dev module.
Or DOIT, ESP32 Devi Kit V1, depends on your specific board.
And then you pick the COM port it showed up as. Just don't pick COM1.
Please don't pick Kai11. That's usually reserved.
All right, hardware connected, IDE configured. Let's get to the code, the famous blink sketch.
The hello world of hardware. It's beautifully simple, but proves so much. We're targeting the little onboard blue LED.
Which is pretty much always connected to GPIO pin 2 on these boards, right?
Almost universally, yes. Pin 2.
So the code structure, you've got setup, which runs just once.
Right, and that's where you tell the ESP32, hey, pin 2, you're going to be an OutTPT.
And then the loop function takes over, running again and again.
Forever. And the logic inside is dead simple.
You use digital write, LED pin, high GH. That sends voltage, turns the LED on.
Correct. High GH means on. Then delay, 1000.
For 1 second, 1,000 milliseconds.
Then the opposite. Digital write, LED pin, low in, cut the voltage, LED off.
And another delay, 1,000. Wait another second. On, wait, off, wait.
That's it. That simple high H-low cycle tells you the whole chain is working. IDE, cable, drivers, chip, code execution. You're in control.